Hi all, we are starting a free open lecture in our Discord. Our sessions are held weekly, without interruptions. If you, the viewer, want to ask questions online and receive answers, join our lectures. You can find the link to Discord in our Telegram channel. To find out the schedule for the educational lectures, become a member of our Telegram channel and updates. We have an array. Well, as for the array, we actually have a permutation from 1 to n, where n is the size of the array. There is a mech function with a coefficient k, where k is the kth positive integer in ascending order that has not yet appeared in the set. Accordingly, we can denote the meow function for some, subset A as mech, where we are looking for b plus the first positive number that we do not yet have in this set, where b is the length of the given set. The meow function is crucial in determining the mathematical properties of the subset, and it helps us understand the underlying structure of the data. What we need to find here is the sum of all values of all possible meow values for different subsets of 2b of array A, and we have a constraint of 5000, totaling 5000. This constraint is significant because it limits the number of operations we can perform, ensuring that our calculations remain efficient and within the bounds of computational feasibility. So we can even say yes in the square of 25 times 10 to the 6, which represents a large number, indicating the complexity and scale of the problem we are dealing with. We need to output the number of ways to achieve such a meow. We have tests on how we can obtain it. So TFSP, just a diagram perhaps. These tests are designed to validate our approach and ensure that our method is robust and reliable. The diagram serves as a visual aid to help us conceptualize the problem and identify potential solutions more effectively. Well, let's break it down simply. Here we have n equal to 2. So I'm clicking copy. Let's say A. I mean the text. I see. Well, by the way, it's strange. Before he would just paste with Ctrl+5 easily. Anyway, he's still just numerically. For 2, what permutation do we have? 1, 2. We are going through all possible subsets and absolutely every single possible combination.
Want to become a great programmer? Subscribe to our Telegram channel.
With the latest news and insights, I am turning on the empty. In the context of set theory, the concept of an empty set is fundamental. For the empty set, we will have meow equal to 1, because the size of the set is 0. In this scenario, adding 1, we get 1. That is, indeed, we are looking for the first element that is not present in the set in order, and the bottle's delivery. Next, we consider a set consisting of the number 1. Its length is 1. Thus, 1 plus 1 equals 2. That is, we are looking for the second meh in sequence, which is not in the set. This number will be 3. Following that, we will search for the same result when it comes to the number 2. In this case, the outcome will also be 3. Actually, ultimately, in the end, we will eventually get meow for 1 and 2. We have a set length of 2. 2 plus 1 equals 3, meaning we are looking for 3 meh in sequence, which will give us 3, 4, and 5. So we add 5 and get 12. This way. This is how it turned out in the test. The problem conditions are clear. We need to find out how we actually get the answer. So, to start with, we have some number n that defines the permutation 1, 2, 3, 4, 5, and then we go up to n. There is a function meh with some seta and a coefficient of size a plus 1. What does this essentially mean? Let's say we have a subset 1, 2, 4, 7. Its length is 4. Its length Accordingly, we get 4 plus 1, which is ultimately 5. And what does this 5 essentially mean? We need to find the fifth positive element in order that is not in the set. What elements do we have? 1, 2, 4, 7. Accordingly, the first element that we do not have is 3. The second one is 5. In short, it's 6 and 8, 9. Accordingly, 9 is our answer to this function. Could you please confirm if this is clear? How exactly is the word laugh written in this context? All right, that sounds great to me. Accordingly, what exactly do we need to find? We have TFSP. In this particular scenario, the permutation is given in this specific way. Therefore, we need to carefully enumerate all possible subsets. A subset of a set is a set that we can obtain by removing any elements. That is, the non-obligatoriness of the edges means that they can be crossed out like this. Here, it doesn't really matter. All of this will be considered a subset. We include the empty set as well, which is an important aspect of our calculation. And we need to calculate our mean for all of this data, sum everything together, and output the answer modulo 10 or 9 plus 7, as usual. Well, that's basically all we need to find here. Now it's clear what we are looking for and how we will obtain it. This process involves considering every possible subset, including the empty set, and ensuring that our calculations are accurate and precise. By summing all the values and applying the modulo operation, we ensure that our result is within the expected range and format. That is, we essentially enumerate each and every possible subset of the permutation for all of them. We are looking for the mean, just like that. We sum it up, and then everything is modulo. We find the remainder. So how exactly is this thing solved, essentially, in essence? Essentially, who exactly are we basically enumerating? We are enumerating the size of the set, the composition of the set, and the subset. That is, we have k. This is the size of the subset that we used. We will create a gradation for it. Accordingly, from 1 to k, there are two types. It is either 2 times k, which is greater than or equal to the number n in the mathematical equation, or less in the context of this problem. For the first case, this will indeed actually be the case. In other words, that is, if the length of the given subset, which is denoted as k, and it turns out that when 2 is multiplied by k, this result is greater than or equal to n. In this case, we will always definitely have an answer for the mean, regardless of what we choose in the set 2k. Plus 1. Why is that? Because in essence, no matter what we choose from the original subset, our mean will be so significantly far that it will indeed encompass all the elements of the original permutation. It doesn't matter what roles we play or which elements we have selected from this original permutation. It will make no difference. For example, we have a permutation is of length 7 and k will be of length 5. And then it actually turns out we can pick 1, 3, 4 for ourselves there. And for the sixth experiment, we'll go with 6 and 7. Accordingly, the mech we have will be the sixth in the count, and here is what we get. The first in the count is the mech, which is 2. And then, approximately 5 seconds later, then 5. We begin with the numbers 8, 9, 10, and 11. Notice that 11 appears again, marking the sixth count in the mechanical sequence. We could obtain the same mech simply by calculating 5 times 2 plus 1. If we have k greater than half of n, then we will always have the answer for mech as 2 times k plus 1. And thus, Accordingly, for each integer k that is greater than half of the integer n, where n represents the total number of elements in the set, we can simply add the number of ways to choose such a k from the given substance, which is the set of elements we are considering, to the answer. This is done by multiplying the result by 2k plus 1. For example, if n is 10 and k is 6, we calculate the number of ways to choose k from the substance, and then multiply by 13, which is 2 times 6 plus 1, to get the contribution to the answer. For all k of this first type, we can certainly and indeed without delay add this answer and disregard such a thing. And for the second type, whatever the situation, if k is less than half, it means that our mech, regardless of its count, is located within the original permutation. That is, specifically, our advanced mech will be in this range. That is, it cannot be less than the length of the subset itself, but it also cannot be greater than the entire original permutation. So it will be located within this space. Based on this, from where the mech is exactly located in the mass, we can also precisely calculate the answer. That is, let the mech be located somewhere around here. What does this mean? It means that we will have an here, and let's say we have one here. Here we have 2000 plus 1, and accordingly, from the remaining elements, we have a permutation. That is, if the mechanism is equal to this particular element, then after that, there are no elements in our subset. Specifically speaking, to be precise, it's not that there are no elements, but rather that they do not interfere with our situation in this particular scenario. In fact, as a matter of fact, we can include any elements that are greater than the mechanism in the quantity of 2000 plus 1 minus I in the overall picture. That is, within this interval, any I can be selected that is greater than, but less than, or equal to n. But reduced equal to n. Accordingly, in a mathematical context, the enumeration of these individual elements has the potential to be effectively represented as the number of combinations. That is for the number of combinations from nmech, which means on this segment we are essentially looking for such a quantity of elements. Thus, it results in 2k plus 1 minus, accordingly, what is exactly happening at the other end of the mech. We have some number of elements precisely at the moment. And with the fir minus 1, we get how many elements that have been selected and how many we have actually filled in here, which is 2k. Yes, certainly, we can fill in any element here, and we will get what we have gathered here, which is 2k plus 1 fir. Yes, it is quite clear why we gathered. In this way, we need to gather. So, if the length of the fir is minus 1, then how many elements do we have to choose from? And what we need to gather is that, in any case, we will have a combination of fir minus 1 by approximately subtracting. Consider a sequence starting with fir, then subtracting 1, and continuing this pattern until you reach minus k. Could this be the scenario perhaps? So here we are iterating over what we have collected from the end, which will not affect the fir at all. To clarify, this iteration process is carefully designed to ensure that it does not interfere with or alter the fir in any manner. And here we are iterating. Well, yes, minus k, because these are exactly the elements that we have also collected and which are also neutralized. This neutralization is crucial as it ensures that these elements do not contribute to any changes in the fir. Since the remaining k elements will be the previous firs, it is important to understand that these elements are distinct from the ones we are currently iterating over. So in this case, we will include our fir in the answer. This inclusion is significant because it allows us to account for all elements in our final result, ensuring that nothing is overlooked or omitted in the process.
Want to become a great programmer? Subscribe to our Telegram channel.